Okay, so we're going to look at inverse functions. And inverse means opposite operations that undo each other. So some examples, you've got addition and subtraction, which are inverses, multiplication and division that are inverses, something squared and something square root, those are inverses. You're just undoing the operation. So when you first learn to solve equations, you use inverses a lot. So inverse functions, by definition, if f is a one-to-one function, so there's only one x per every y, with a domain D and range R, then the inverse function of f, denoted f to the negative 1, is the function with domain R and range D, defined by this statement below. So f inverse of b equals a if and only if f of a equals b. So your domain and range switch. All those words, that's what it's telling you, domain and range switch. So then if you look at a graph, if you pick out a couple of points, if you have a point AB, then its inverse is going to be BA, domain and range switch, X and Y switch. It's a reflection over the line Y equals X. So if you look at the graph, hopefully you're able to see, oh, that's what it looks like. So it just kind of flips on its side. It's by definition reflected over the line Y equals X. And so graphically you can see it. So you've got three examples there. That first one all the way to the left is a cubic function. And so if you think about your parent functions, that green one is a cubic and the red line is a cube root. So you know that those are inverses. And the second one, the middle one, the green one is a quadratic and the red one is both sides of a square root function. And then that third one is just a linear function. So for this course, we're primarily going to focus on finding the inverse function, and to do that, we're going to follow 4 steps. So first, replace f of x with y if that's not already done. Swap your x and y value. That's important because that's what makes it the inverse. And then you're going to solve for y, and then you're going to rename it using that inverse function notation. So we'll go through a couple of examples. So if you've got a table to find the inverse, all you have to do is swap that x and y. And so if you'll look at the first table and then the second table, you see that the columns are just switched. Easy enough. So now if we actually find the function notation, we've got those 4 steps off to the left. If we start with 3x minus 6, first step is to replace f of x with y. So now you've got y equals. The next step is to swap our x and y. So we've got x equals 3y minus 6, and then you're going to solve, you're going to solve for y just like you would when you're solving an equation. So we'll add 6 to both sides, divide both sides by 3, and then you want to rename the function as an inverse. So we'll look at another example. We've got 0.5y plus 1. That's actually a typo, so it should be an x. So I fixed it in the next step. So f of x equals 0.5x plus 1. Replace your f of x with y. Swap your x and y, and then we're going to solve for y. So remember that 0.5 is the same thing as 1/2. So once we subtract 1 from both sides, to get rid of that 1/2 or that 0.5, we multiply both sides by 2. And you can distribute that 2 if you want to, or you can leave it as is, but make sure you rename it as an inverse. Next example, we've got 5 minus 3x divided by 2. So first things first, we'll replace f of x with y. Then we'll swap our x and y values. Remember, inverse just means a domain and range switch. So we've got x equals 5 minus 3y over 2. To get rid of that division, we'll multiply both sides by 2. Then we'll subtract 5 from both sides. And then we'll divide both sides by negative 3. So there's a couple different ways you can write that. I just left the negative 3 on the bottom, and then I renamed the function. All right. Fifth example, find the inverse. So we'll start with our function. We'll rename f of x, y. They're interchangeable. They mean the same thing. Swap your x and y value. And then we're going to solve for y. So we'll add 4 to both sides. Multiply both sides by 2. and then take the square root. So underneath the square root is that 2 times x plus 4, but since we're using Google Slides, there's not really a good way to write the equation in there. And of course, you can distribute that too if you want to, but you don't have to. And then make sure you rename it with the inverse function, inverse notation. All right, sixth example, we haven't even talked about exponential equations, but I do kind of want to show you that they are inverses and we can find it. And we'll practice with this when we get to exponential. So when you've got a function, it equals 4e to the 5x. Still the same way, rewrite it with a y. Swap your x and y value. We're going to get our base e by itself, so we'll divide both sides by 4. To cancel out the e, we're going to use a natural log. So we'll have a natural log of 1/4 x equals 5y. And if you haven't learned about logarithms yet, that's where that comes from. And then divide both sides by 5. And then replace it with your inverse function notation. So we won't deal with a whole lot of those until we start talking about exponential and logarithmic functions, but I did want to just kind of show that out there. All right, so then we're going to find the inverse function of 9. So if you're given a table to begin with, basically that f inverse of 9, that's your x value for the inverse function, which is your y value of the original function. So you can do it one of two ways. You can just kind of logically think through it, or you can write out your table, and then you can see that f inverse of 9 is 4. And then it's your original x and your original y, just in a different order. So in this course, we're not going to worry about verifying the inverse, but it does exist. We are primarily just going to find the equation, and we already looked at how you can see the inverse from a graph, and that's all we're going to worry about. But if you want to click this link right here, it will take you to how to verify the inverse, and it's just a composition of functions, but we're not going to worry about that. It's a good bonus question if you want to look into it. And that's all we're going to look at for inverse functions.